So there are two rules for determining if a zero, if you're given just a number, a measurement, or a calculated number, and you need to know how many digits are significant. There are two rules for figuring that out. Okay? If you are given a measurement or a calculated number, and you need to figure out what zeros are significant, there are two rules. There's the one-part rule, and there's the two-part rule. The first thing to remember is all non-zero digits are significant, period. Okay? Anything other than zero, any digit other than zero in that number is going to be significant. If it's not a zero, it's significant. So all we have to worry about is zeros. And the one-part rule says, any zeros that are between significant digits, are also significant. Any zeros between significant digits are also significant. Okay? So if I have 40.05 milliliters of milk, well, this 5 is a non-zero digit, it has to be significant. This 4 is a non-zero digit, it has to be significant. And that makes both of the zeros, because they are between significant digits, also significant. Okay? Then there's a two-part rule for significant digits. Okay? The two-part rule says zeros can be significant if they follow both. So here's the two-part. Both. It's got to be both. You can't just have one of the two. It's got to be both of them at the same time. Zeros can be significant if they follow both a non-zero digit and a decimal place. Zeros can be significant if they follow both a non-zero digit and a decimal place. So let's rewrite this number as 40.00 milliliters of milk. Okay? All right. These two zeros follow this decimal place. When I say follow, I'm meaning to the right, because we read left to right. Does that make sense? Okay. So these two zeros follow that decimal place and follow that non-zero digit. Since they meet both parts of the two-part rule, both zeros are significant. And since both these zeros are significant, now this zero meets the one-part rule. One-part rule says a zero is significant if it's between two significant digits. Since these are significant, and this is significant by virtue of the fact that it's not a zero, then the zero here has to be significant. So now we have three significant digits. Okay? Now there's kind of a shortcut rule that's not really part of the main rules. Okay? And the shortcut rule is leading zeros are not significant. Now, that doesn't fit everything, but it's kind of a way of figuring out some simple stuff. For example, if I have 0.0040 milliliters of milk, okay, this zero is significant. This last zero here is significant because it follows a non-zero digit and a decimal place. It's to the right of a non-zero digit and a decimal place. But these three zeros don't meet either one of our other two rules, and they're called leading zeros. So those zeros are not significant, and this one is. So this number has two significant digits. Okay? This number has four significant digits. This number has four significant digits. Okay? Yes. Molly or Aaron, I don't know who had the hand up first.
Okay, so how many significant digits would you have if you had 7.30 times 10 to the negative 7?
Okay. 7.30 times 10 to the negative 7. Okay? Well, both these digits are significant because they're not zeros, right? This zero meets the two-part rule. It follows a non-zero digit and a decimal place. So that 0 is also significant. That means I have 3 significant digits.
So like you just ignore the things that
Yeah, pretty much.
But doesn't that mean that it like goes to
Sure, it does. Let's write that out and see how that plays out, okay? So let's see, 10 to the negative 7. I got 0, 1, 2, 3, 4, 5, 6, and I believe that's going to come out to be 730, right? All right. Are any of these zeros significant?
No, they're leading zeros.
They're leading zeros. They're not going to be significant. So this number here and this number here, this number here and this number here are the same thing, right? And so if you only have 3 significant digits here, only going to have 3 there. Now, scientific notation actually makes it easier to determine how many significant digits you have.
So like you wouldn't have to write it out. You could just tell them like all the time.
I'm sorry. Try that again.
No matter what you have, if it's scientific notation, you can tell.
Oh, yeah. That's what I was getting to. In scientific notation, if it's written properly, and that's the caveat here, that's really important, it's got to be written properly. Scientific notation written properly will have no insignificant digits. Don't sweat it and don't have a conniption fit over that. Just take my word for it, okay? Are there any insignificant digits here? Okay. Okay. Because now scientific notation to be written properly has to have the decimal place between the first and second non-zero digit. First and second reading from left to right. Okay, we read in English here, not in Hebrew, so we're reading from left to right. Okay? Yes, Molly? Sure. Yeah, this is kind of a shortcut for chemists. If I want to write this number, and show that these two zeros are significant, I could write 7.00 times 10 to the second grams of sugar. Okay? But just to make it simple, chemists kind of do that a lot of time. Because and when I put a decimal place right there, that tells me these two zeros are significant. Okay?
So when it's in scientific notation, we just assume that if decimal point is at the end, so all of it is
I'm confused by your question.
in scientific notation, when it's not a negative, obviously, do we just assume that the decimal point is still at the end, so all of the digits are significant, or do we?
I'm not sure I understand about decimal place at the end. That's the part that confuses me. Okay? If I write this, then the decimal place is at the end. Is that what you mean to say?
Yeah, that's what
Stu, are you not paying attention? I'm answering her question.
If it was just scientific notation, and you use the decimal point to the end so that you have the number.
When you say to the end, in scientific notation, the decimal place goes not to the end between the first and second non-zero digit.
Yeah, but I mean, like, when you write it out. So it wouldn't be in scientific notation.
Well, if I write this out, I have to put that decimal place there to show that there's a significant number there in one place. And actually, you know what? This actually brings a good point. I said the decimal place must be between the first and second non-zero digit. That's not really true because obviously this is not a non-zero digit. So the decimal place has to be to the right of the first non-zero digit. Okay? That's correct. Yep.
I'm just saying, if you were given a problem that was in scientific notation and you wrote it out, would you count all of those as significant digits?
No. Only the ones that meet all the rules.
Okay.
It goes back to this one up here. Okay? These zeros are not significant when I write out this way. Only those three are significant. But they meet the two rules about significant zeros. But what I'm saying is in scientific, or what I said earlier was, in scientific notation, one of the benefits of writing in scientific notation is all the digits in a properly written scientific notation number will be significant.